right. Hello, everyone, and welcome back. We're continuing on. We're finally at a Unit 1, but Unit 1 is one of the longer course sections of the course. And we're going to go to the next longest section, which is Unit 2. And after Unit 1 and 2, we actually go through the course fairly quickly. So I'm going to give that spiel again, but I got to hit the record button first. So let's go ahead and do that, just in case. We record our screen. Yes, we do. Okay. Hello, everyone, and welcome back. We are now working on Unit 2 of MCT4C, and we're having a look at long division of polynomials. So here we are on, our course here is MCT4C, the Math for College Technologies, and here we're working on Lesson 6, Part 1 of 2. In this lesson, we're doing long division. That's it. Well, not quite that's it, but that's like the main component of it. And so all we're going to be looking at today is a topic which you might have seen before, but perhaps disliked, which was namely numerical division. And I mean like a 4-digit number divided by a 1-digit number. And then we're going to have a look at a logical consequence, which is something called quotient form, the corresponding statement. This existed for numerical division. You just oftentimes never used it, but very reasonable. And then something that you may not have realized is that we can combine two words together, polynomial and division. So we'll see how that looks, what that looks like. And we'll know that things went well because for the most part, if you're able to perform polynomial long division and then verify the answer, that's it. That's how you know at the end of the lesson, things went well. Okay. And so if you notice here, we've got a shorter lesson today. It's only 6 pages. And again, that's just due to the fact that we're going to be doing a lot more writing and we're going to be going a lot more slowly through these as well. Okay. And so we're having a look at division, and this is long division. So we have 1,452 divided by 5. And so we're going to take 5 and we're going to try to divide it into 1,452. Okay. And so the algorithm that we're going to use to solve this is going to be identical to the algorithm we're going to be using to work with long division of polynomials. Okay, and I believe this is going to cover key question 1, where key question 1 is just do all long division. It's quite a lengthy lesson, question 1 of lesson 6. Okay, so first thing we want to do is we want to ask the question, how many times does 5 go into 1 of 1,000? And the answer is technically not, so we need another digit. How many times does 5 go into 14? And so we can see that it goes into there twice. And so on this line, and I'm being very particular about how I'm writing this today, because I'm going to be writing this the same way for the most part. We want to write 5 times 2. So we want the smallest number. So we want to see how many times 5 goes into 14 without going over. So 5 times 2 is 10, but 5 times 3 is 15. 15 is larger than 14. So on this line, we're going to write 5 times 2, which is going to be 10. And then we're going to subtract these terms. So 14 minus 10 is going to give us 4. We mark off. And you can, some people either use an X. I'm going to, for the next one, I'll show you drawing an arrow down. And they bring down the 5. Okay, so the question becomes now, how many times does 5 go into 45 evenly without going over? And so for this one, that's going to be 9 times. So on this line, we're going to be writing 5 multiplied by 2. Oh, not 2, multiplied by 9, sorry. So 5 times 9 happens to be 45. And then we subtract this. What's 45 minus 45? Is 0. The only thing I'd be cautioned against, don't try to, you might run into a situation where it's like, say, 23 minus 19. don't try to mess around with trying to carry. Just think about what 23 minus 19 is, and it's 4. Don't try to do the shorthand subtraction there. Okay, because otherwise it'll get quite messy. Okay, next thing we do is bring down the 2. So you might have also written it like this. I prefer using the little X's just to note that I've used that digit because this is going to get quite messy. And I already have some arrows here for some reason, which you'll see why in a bit. Okay, so we write down our 2 down below. And the question becomes, how many times does 5 go into 2? And we're like, well, 5 doesn't go into 2 even, right? It goes in a total of 0 times. And so on this line, we write 5 multiplied by 0. So 5 times 0 is just 0. And so we want to subtract the 2 quantities. What's 2 minus 0? And as it turns out, it's 2. And if you notice here, I've run out of digits. And from the past, you might remember, hey, do we just start putting in decimals? No. For our purposes here, we are not concerned with decimals. Okay. So that's what our long division looks like. And so we could say, or if you would like, so we could say that 1,452 divided by 5 is equal to 290 and a remainder of 2. Okay, and if you look on the left side here, I could just check my calculator pretty quickly. 1452 divided by 5, and we can see it's 290.4, which makes sense because remember, that's 0.4 is the same thing as 2 over 5. But we have notation for this, but I'm going to just save it for the meanwhile, and I'll come back up here and write it. Okay. So that's long division. We're going to do another numerical example because, again, I want you to get used to the algorithm. You might have, depending on which elementary school you went to, and like your age, you might have done long division like this. You actually might have never done this before. You might have done something called repeated subtraction. And you might be thinking, is that going to work for this? And unfortunately, the answer to that is no. You need to learn long division, and you need to practice this. Okay? So let's continue on. So next one here, we have 7,942 divided by 6. Okay, fair enough. So we want to take 6 and we want to see how many times it divides into 7,942. Okay, so first question is, how many times does 6 go into 7? The answer is once. So on this line, we're going to write 6 multiplied by 1. I'm being purposeful on this one. I don't want to write this 6, the natural looking 6 times 1 like this, because we're about to do this with polynomials, and I don't want to have multiplication signs with my x's, so I prefer to just write the bracket notation for this. Okay, so 6 times 1 is 6, so it goes here. And so we say, okay, so what's 7 minus 6? And the answer to that is just 1. It's worth noting as well that if you'd like, you could bring down all of the terms like such. You don't have to just bring them down one at a time, but it ends up being quite clunky, and I find that takes away understanding. So we'll just do these just one at a time, running through the algorithm. Okay, next question is how many times can 6 go into 19 before we go over? The answer is 3 times. So on this line, we're going to write 6 multiplied, or 6 bracket 3. So 6 times 3 is 18. And we're answering the question, 19 minus 18 is 1. Bring down the 2. Okay, how many times does 6 go into 12? The answer is 2. So on this line, and if you do this on line paper, again, like you would just make sure, don't try to write more than one number in each of the spaces, just one number per space. So on this line, we're going to write 6 multiplied by 2. So 6 times 2 is 12. So 12 minus 12 is 0. Bring down the 4. And so lastly, the question becomes, how many times does 6 go into 4? Well, 6 doesn't go into 4. It goes in 0 times. That'd be correct. So on this line, we're going to write 6 multiplied by 0. So 6 times 0 is 0. We minus these off. 4 minus 0 is just 4. And we have run out of numbers here, which is great. And so we could say that 7,942, divided by 6 is equal to 1,320. And then we say it has remainder 4. So we might say like R4. I use more words up here to represent that, but we can also just represent this mathematically as well. So 1,320, comma, remainder 4, if you so choose. I can check this on the calculator. The answer to this should be 1,320.66. So if I take 7,942 divided by 6, we end up getting, we end up getting the right number here. Oh, I did the thing from earlier. So, I mixed up the order of these. Should be 7,924 because that's what I ended up doing. That's why I was like, how did I get this wrong? And I was like, oh, that's why. The same thing I wrote earlier. Okay, there we go. So my calculator answer is slightly off. So let's go ahead and redo that. 7,924 divided by 6. There it is. So we end up getting the right answer, assuming we had to change the number, which sometimes we do. So if you were watching this on YouTube and you're like, oh, is he going to catch it? The answer is yes, I would. But we are recording live, so we are committed. So with that in mind, I would recommend pausing the video and going ahead and trying out some more 4-digit division. And I only picked 4 because four digits divided by a 1-digit is sufficiently complicated for solving this. Don't divide by a 2-digit number. That's going to take too long. Okay, so we have a concept. So we alluded to this earlier. And unfortunately, now that I've wonderfully done this, I got to change this up slightly. So if I have 7,000, so there's something called quotient form. So quotient form says if you have the dividend divided by the divisor, that's equal to the quotient plus the remainder over the divisor. So this is what quotient form would look like. So I'd have the answer from above, 7,924 divided by 6 is equal to 1,320 plus 4 over 6. So this is what we call quotient form. Okay. We were pretty much in our little therefore statement up here. This was pretty close to quotient form, except we would have written 4 over 6 as a remainder at the end. So quotient form is much more useful in later math classes, as it turns out. This is actually the primary method we want to write these things as. But in this class, it's just important to understand what this is. The one that ends up being actually quite useful is what we call the corresponding statement. And again, unfortunately, I'm going to try to color code this as best I can. Where if you want to check to make sure this works, you could just type this in. So you would just take your divisor times the quotient and then add on the remainder. So the example we had up here, which this one I did correctly, this one I didn't copy it down wrong, is if I wanted to check out the corresponding statement, I would say that 1452 is equal to 5 times 290 plus 2. And so if I were to take 5 times 290 plus 2, I get the correct answer. And in this course, the corresponding statement is actually the one we're going to be ending up using a lot to kind of fill in our understanding of polynomials. Yeah, sorry, to fill in our understanding of, to make sure we did things correctly. Because again, it's very reasonable to do something I did. Like I just mixed up the order of the 2 and the 4, which was unfortunate, but alas, here we are. Okay, so for all questions coming up, they're pretty much going to ask us to write this either in quotient form or corresponding statement to make sure we know what to do. And so we're going to spend the next 40 or so odd minutes doing long division and checking our answers. So let's not waste any more time here and let's have a look. Okay, so we're going to start off with an easy one. So we're doing example 1, and I think there's a few examples of this. We're going to divide x squared plus 4x plus 3 by x plus 1, and we're going to write our solution in quotient form. You're like, you can do this? Yes, you can. So first thing we do, we start off by writing the exact same thing as before. We have our x plus 1 goes here. That's our divisor. The dividend is this x squared plus 4x plus 3. And the first question we ask ourselves is, now you might be wondering, what do we do with this plus? Like, well, how do we work with this? Actually, primarily, we want to be thinking in terms of the first. So we're dividing by a binomial. You want to be thinking about dividing by the largest degree thing. So here we're dividing by, we want to be thinking primarily in terms of x. And this plus 1 will be just kind of tacked on as a consideration. But you'll see what I mean. So the question becomes, how many times does x go into x squared? And so another way to think about that is if I take x squared divided by x, what do I get? Well, how many times does x go into x squared? It goes in x times. And so on this line here, I'm going to write x. And so on the line below, I'm going to write x multiplied by the divisor, which is x plus 1. Okay, and you can see a lot of parallels with what we've been writing earlier, right? We were asking ourselves how many times the 6 go into the number, and so we could have been writing this as a 7 over 6, which is 1 in a bit. So we're doing kind of the same idea. So I have this little green notation over here to represent kind of some of our thoughts process as we go through this. Unfortunately, I gotta get rid of these arrows because it's going to be in the way. And so the question and so now what goes on this line? Well, x times x is x squared. X times 1 is positive x. Okay, now I mentioned that we subtract, right? Because we still have to do that. And so we want to subtract the quantity x squared plus x from x squared plus 4x. And so we know, so for notation purposes, I like putting brackets around the thing that I'm minusing just to emphasize that I'm minusing off this quantity. So what we're trying to resolve here is we want to know what x squared plus 4x minus, in brackets, x squared plus x. That's what we're working with. But we're organizing this vertically. So x squared minus x squared is 0 by design. 4x minus x is going to give us 3x. Okay, because remember, we're minusing that off. And so we mark off the 3 and we bring it down. And so what's the question now? How many times does x go into 3x? So the little chicken scratch we're doing off to the side is, if we take 3x divided by x, what does this give us? Well, x goes into 3x 3 times. An easy example to think about that would be how many, if you have a pile of 3 apples, how many times can you take 1 apple away? You can take 1 apple away a total of 3 times. And that's the equivalent here. And so on this line, and unfortunately, it's important to note that how many times does this x go into 3x? It goes in positive 3 times, because yes, you could have negatives here, and we in fact will have that on the next one. And so on this line, we will have x divided by x plus 1. And so x times x is going to give us, we write a 3 here. Sorry, I'm color coding sometimes. I forget to do things. Okay, so 3 times x is going to give us 3x. 3 times 1 is going to give us positive 3. And so we will subtract this off. So 3x minus 3x is 0. 3 minus 3 is 0. So by coincidence, if we were to take, and we want to write our answer in corresponding, in quotient form, so we'll call this QF for quotient form to save on time, we will say that if I take x squared plus 4x plus 3 and divide it by x plus 1, I get as an answer x plus 3. Now, you might be saying, do we write the remainder? No need to write the remainder. So we say that we're just complete at this point. So this is now in quotient form. The reason why there's a remainder of 0 is because actually x plus 1 happens to be a factor of this, so you always get a remainder of 0. So that's a topic we're going to study on Wednesday, which is an important consequence. But again, for now, we're going through the algorithm. Okay, so let's continue on. This is all we're going to do for the rest of the day, this kind of stuff, and then check our answers. Okay, so letter B, we're going to divide x squared minus 3x plus 5 by x minus 2. And we're going to write the corresponding statement. Okay. And so first thing we want to do is how many times does x go into x squared? So we're answering the question x squared over x. So how many times does x go into x squared? And the answer to that is just x times. So we're going to write the x above. So if you notice here, I'm trying to line up my x values. So like the x goes above the negative 3x term and so forth. Okay, so on this line, I want to write x multiplied by x minus 2. So x times x is x squared. X times negative 2 is negative 2x. And so we want to then subtract off these quantities. So x squared minus x squared is 0. If this is never not true, that means something went wrong, which can happen. And negative 3 minus 2x is the same thing as negative 3 plus 2 of the x variety, which means we get just an x. Okay, and we're going to bring it down to our plus 5. And so the question becomes, how many times does x go into x? So we're answering what's x divided by x is 1. So we're going to write plus 1. Oh. And you can see some of the difficulty that's come with now. So here, remember, it's negative 3x minus 2x. So this is going to be negative x. So our answer is going to be negative here. And so how many times does x go into negative x? Well, this is the same thing as asking negative x divided by x, which is negative 1. So this is how you can end up with these negative numbers here. And so up here, we're going to write our minus 1. And then on this line, we're going to write x You're going to write -1 multiplied by x minus 2. Okay. So when we do this, -1 times x is going to give us negative x. -1 times -2 is going to give us positive 2. And we want to subtract off these quantities. So something you're going to want to notice is that as you're going through these, when we do the subtraction, those should ideally be the same. So it should be like x squared minus x squared, great. Negative x and a negative x, that means you know things are going well. Oh, I don't want that one. And so we minus this off. Negative x minus negative x is 0. 5 minus 2 is 3. And now the question is, can x go into 3? No, it can't. Can't be done. So if I try to write that off to the side, remember x divide. If I try to write, say, 3 divided by x, that doesn't make any sense. Can't be done. And so the corresponding statement will be that x squared minus 3x plus 5 is equal to the divisor, which is going to be x minus 2 times the quotient, which is x minus 1. And then we just tack on the remainder. So in this case, we have plus 3. So this is what we call our corresponding statement, which we'll call CS. Now, the benefit of the corresponding statement is that it's an easy way to check your answer. Because I can just expand out the right side to make sure I get the left side. So x times x, and I should mention at this point this is a complete solution, that's done, but we're just going to check our answer to see what the purpose of the corresponding statement is. So x times x is x squared, x times -1 is negative x, -2 times x is negative 2x, -2 times -1 is positive 2, plus 3. And so we have an x squared left over. Negative x minus 2x is negative 3x. 2 plus 3 is 5. And so we can see that the left side is equal to the right side. Okay. So the main difficulty you're going to run into this is just pretty much just an organizational concern. You want to make sure as we're working through this, things are laid out in some logical manner, because it's pretty easy to make little mistakes like how I did earlier and just like forget what I'm working with. Okay. All right. Let's continue on. So the question was there anything special about using quadratics? No, quadratics are shorter, which is why we started with them. But really what we want to be doing is taking cubics and quartics and dividing by something. So we're going to take x cubed, or x to the power of 3, minus 5x squared, plus 10x, minus 15. And we want to divide that by x minus 3. And you might be thinking, is it always going to be like x minus or x plus something? For the most part, yes. Unfortunately, you can do this as well with something like 2x plus 1, and you end up with fractions. So it makes it more difficult to work with, but it is still doable. Okay, so the question becomes, how many times does x go into x to the power of 3? So if I take x to the power of 3 divided by x, that gives me x squared. So that's what goes up top. And we try to line them up. So the x squared will go above the negative 5x squared. So on this line, I'm going to write x squared multiplied by x minus 3. Okay, so x squared times x is going to be x to the power of 3. X squared times negative 3 is going to be negative 3x squared. And again, we want to minus this. Now, I mentioned earlier, could you also just bring down the other terms? Yes, but now you see the reason why I don't want to bring down the other terms. So for example, I don't want to write this as plus 10x minus 15 because it just becomes quite lengthy to work with. And we don't want to introduce extra considerations when we don't really necessarily need to. Okay, so x to the power of 3 minus x to the power of 3 is 0. Great, that works. Negative 5 minus negative 3 is going to be 8 of the x squared variety. Okay, looks good. So then the question becomes, how many times does x go into 8x squared? So we're going to write off to the side 8x squared divided by x. So x goes into x squared once, so it's going to go 8x times. Great. So it's positive, so we're going to put that up there, positive 8x. And on this line, I'm going to write 8x multiplied by x minus 3. So there, bring down my 10x. So 8x times x is 8x squared. 8x times negative 3 is going to be negative 24x. Okay, so we want to minus this off. So 8x squared minus 8x squared is 0, which works. That's what it should be. And 10 minus negative 24 is going to give us 34 of the x variety. And then we're going to bring down this minus 15. So a very logical question you might be thinking of is, I noticed that we got 34x is quite big. Did you make a mistake there? I'm like, unfortunately, when you're going to end up with a remainder, a lot of the time it's going to be not a small number. Like you can very easily end up with these large numbers. So, and we're going to see why that is the case in a bit. But for now, just realize that if you run into things like 34x minus 15, that there's a good chance that that's probably just still correct, but the number's just quite large. Okay, so next we're going to ask, how many times does x go into 34x? And the answer is it goes in 34 times. And so it's going to go in positive 34 times. So we're going to write plus 34. And so on this line, we write 34 multiplied by x minus 3. So 34 times x is going to be 34x. 34 times negative 3. That's why we have a calculator off to the side. So it's going to be 102 of the negative variety. And then we want to subtract off this quantity. So we'll put a bracket around here. I have found in my experience, putting this bracket does make it easier to think about, because the mistake I see students do is that they'll write 34 minus 34, which is 0, but then just only have it as negative 15 minus 102, but that's not the case. Okay, so this is going to be negative 15 plus 102, which is going to be 87. And so x doesn't go into 87, and in quotient form, our solution will be that x cubed minus 5x squared plus 10x minus 15 divided by x minus 3 is the same thing as x squared plus 8x plus 34 plus sign 87 over top of x minus 3. So remember, this is going to be our quotient form. Since we made an abbreviation, that quotient form was QF. Okay, and again, in this math class, this is not particularly helpful, but in future math classes, extremely helpful, and in fact is the main way you want to be thinking about these things. Because as it turns out, if you have to do something with this, the right side is much easier to work with, which is not intuitive for the moment, but alas, here we are. Okay. So for D, we're going to divide 3x to the power of 3 plus 2x to the power of 2 minus 6x plus 5 by this x plus 2, and we're going to write the corresponding statement. Okay, so first thing we're going to do is write our 3x to the power of 3 plus 2x squared minus 6x plus 5. And we're going to divide this into, or to have this divided by x plus 2. Now, you might have noticed a pattern here. And if you didn't, that's okay. So if we took a quadratic and divided by a linear expression, we got a linear expression. If we took this cubic, or degree 3 polynomial, and divided by a degree 1 polynomial, we got a degree 2 polynomial. That's not an accident. In fact, that's always what happens. So if you have, say, a degree 7 polynomial and you divide by a degree 1 polynomial, you'll end up with a degree 6 polynomial. Get things between. Okay, first thing we want to do, how many times does x go into 3x to the power of 3? So off to the way off to the side, we can say 3x to the power of 3 divided by x is 3x squared. So on this line, we're going to take our 3x to the power of 2, multiply it by x plus 2. So 3x squared times x is going to give us 3x cubed. 3x squared times 2 is going to give us 6x squared. And we want to make sure we subtract this quantity. So 3x cubed minus 3x cubed is 0. By design, that works. If you notice from above, these were always the same when we were subtracting these, is how we know we did this right. And that still continues to hold for now. Well, still continues to hold with these. So 2 minus 6 is going to give us negative 4x squared. And we're going to bring down the negative 6x. So the question becomes, how many times does x go into negative 4x squared? And the answer is it goes in negative 4x times. And so we'll write our negative 4x here. And on this line, we're going to write negative 4x multiplied by x plus 2. So negative 4x times x is negative 4x squared by design. Negative 4x times 2 is negative 8x. So we're going to minus these off. So negative 4 minus negative 4 is 0. Negative 6 minus negative 8 is going to give us a positive 2x. And we're going to bring down this plus 5. So 2x divided by x will be equal to 2. And just a positive 2, so we're going to write that above. So it's going to be plus 2. And so on this line, we're going to write 2 multiplied by x plus 2. So 2 times x is 2x. 2 times 2 is going to give us positive 4. And we want to subtract this. So 2x minus 2x, 0. 5 minus 4 is 1. And so writing this as the corresponding statement, we can see that if we have 3x to the power of 3 plus 2x to the power of 2 minus 6x plus 5 is the same thing as x plus 2 multiplied by 3x squared minus 4x plus 2, and we have a remainder of 1. So this is what we call the corresponding statement. So question E asks us to verify this is the case. And so we want to make sure that 3x to the power of 3 plus 2x to the power of 2 minus 6x plus 5 is equal to what we set up here. So we have to expand this out. So x times 3x squared is 3x cubed. X times negative 4x is going to be negative 4x squared. X times 2 is going to give us 2x. 2 times 3x squared is going to give us 6x squared. 2 times negative 4 is going to give us negative 8x. 2 times 2 is going to give us 4, and then we plus 1. And you can already immediately see that you're like, it's a lot of work. Yes. The nice thing about this is that if you're ever rusty in your algebra skills, this helps out quite a bit because there's a lot of simplifying terms, lots of organization, lots of just pure algebra, which makes it actually quite reasonable to go through in terms of helping to improve your skills. Okay, so we have a 3x cubed is by itself. So for the next like term, we got a negative 4 plus 6. So this is a plus 2x squared. We have a 2 minus 8, so that's going to be minus 6x. And then we have 4 plus 1, which is 5. And so we can see that our left side is equal to our right side, which means we did it right. Okay, so you can always use the corresponding statement to check to make sure that you did it right. And if you're going through this and say they don't match, like, but you got the first couple of terms right, that means something might have went on kind of further down. So so here, if for example the negative 6x was wrong, then that means there was something you did wrong kind of in the last step. Okay. So as promised, why not only divide by x? Let's divide by 2x minus 3. And now importantly, if you notice, this is out of order. So these need to be in descending degree order in order for this to work. Okay, so here we're going to take 2x minus 3 and divide it into. So the first thing we need is a negative 4x to the power of 3. Then we need our plus 6x squared. Then we write our 4x. Then we write our minus 7. This one, they don't care about the corresponding statement, so we won't worry about that. Okay, so the question becomes, how many times does 2x go into negative 4x cubed? So 2 goes into 4, negative 2 times. X goes into x to the power of 3, x squared times. And so on this line, we're going to write negative 2x to the power of 2. And so here, we're going to have negative 2x to the power of 2 multiplied by 2x minus 3. So negative 2x squared times 2x is going to be negative 4x to the power of 3. Negative 2x squared times negative 3 is going to be positive 6x squared. And we are looking to minus these. So negative 4x cubed is 4x cubed, 0, right? 6x squared minus 6x squared, also 0. So a little bit of a hiccup is like, well, what happens here? Oh, we just instead just copy down our x terms. So we just kind of shift over a bit and say, oh, okay, well, we have our 4x minus 7. Because remember, you can still write this as, say, 0 plus. Like if you want to try to preserve it, but it's not necessary. For this, you can just move on to the next step instead. Okay, so what do we need to answer now? So we see that we've skipped over the x term, so now we actually have a little bit of a blank here, right? And yeah, we do. So here we want to figure out how many times 4x can be divided by 2x. The answer is it goes into it twice, of the positive variety. And so not here, not beside it, but actually in the place next to it, we can write a plus 2. And so on this line, we'll take 2 multiplied by 2x minus 3. So 2 times 2x is going to give us 4x. 2 times negative 3 is going to give us negative 6. And so we can minus these off. 4x minus 4x is 0. Negative 7 minus negative 6 is going to give us positive 13. Oh. Yes. Nope. Negative 7 minus negative 6 is going to give us a negative 1. Go. And so if you wanted to check this, we could say that negative 4x cubed plus 6x squared plus 4x minus 7 is equal to 2x minus 3 times negative 2x to the power of 2 plus 2, and then we just have a remainder of negative 1. Okay, so again, a little bit more complicated. And here we were dividing by a term that did not have, that was the leading coefficient was not a 1. In fact, it was a 2. And the only thing that usually happens is normally you end up with nice numbers. It's very rare you end up with fractions, and I don't think we end up with them in this course. But I wanted to show you one example where we ran into a hiccup where we had a seemingly 0 term in the middle of this, and also the case where we started with a coefficient unequal to 1. Okay. So the question becomes, can we do anything else? Sure. Like, why stop with dividing by linear terms? Why don't we instead divide by a quadratic term? And so we're going to be taking x squared plus 3x minus 18, and we're going to divide that into x to the power of 4 minus 25x to the power of 2 plus 62x minus 36. Now, we have a small consideration. Notice here that we are missing a cubic term. So we actually need to put in a placeholder term in order to make this work. And so that placeholder term is actually just needs a 0x cubed. So here, ensure to write placeholder terms. And I suppose I'll write this one in green so it stands out a bit better. It doesn't change the math at all. The reason why we need it is because when we do the subtraction, you might be thinking, oh, this seems pretty reasonable, right? Like, what's our next step here? Well, the only thing that's going to change is that we now have a quadratic term, but we're still going through the same process. So the question is how many times does x squared go into x to the power of 4? So if I have, say, x to the power of 4 divided by x squared, that's going to go in x squared times. So here, I'm going to write my x squared. And on this line, I'm going to write x squared multiplied by x squared plus 3x minus 18. So x squared times x squared is going to be x to the power of 4. X squared times 3x is going to give us 3x cubed. X squared times negative 18 is going to give us negative 18x squared. And again, just like before, the only thing that happens now is that we're subtracting a larger term, and we have more terms. So x to the power of 4 minus x to the power of 4 is 0. 0 minus 3x cubed is going to be negative 3x cubed. Negative 25 minus negative 18 of the x squared variety is going to be plus 7x. And then we just bring down that 62x afterwards. And so then we ask ourselves the question, how many times does x squared go into negative 3x cubed? And the answer is negative 3x times. So we're going to write minus 3x on this line. And we're going to multiply it by x squared plus 3x minus 18. Okay, so negative 3x times x squared is going to be negative 3x cubed. Negative 3x times positive 3x is negative 9x. Negative 3x times negative 18, 20 minus 6. So that's going to be 54 of the x variety. Okay, and we just minus this off. So negative 3x cubed minus negative 3x cubed, just checking my multiplication here, is 0. 7 minus negative 9 is 7 plus 9, so that's going to be 16x. 62 minus 54 is going to give us 8 of the x variety. Oh, choose there, 8x, and then we're going to bring down the minus 36. Okay. Last one is going to be how many times the 16, how many times does x squared go into 16x squared? And it's going to go in 16 times. So we're going to write plus 16. And on this line, we're going to write 16 times x squared plus 3x minus 18. Okay, so 16x squared times 16 times the x squared is going to be 16x squared. 16 times 3 is going to be 48. And 16 times 18 is going to be 288, the negative variety. This question I actually took from the support questions in the lesson. And I know, and the answer had this large number at the end. So just be aware that this can happen where you can get these large numbers on the end. So I took this one's directly from a support question. Okay, so 16x squared minus 16x squared is 0. 8 minus 48 is going to be negative 40x. And then negative 36 plus 288 is going to be 252. Now it asks us to verify our questions, but I noticed that we only have a few minutes left, but it's okay. That is to be expected for today. Okay. So we don't have time, quite have time for that. So we're just going to leave that for now. But the support question will match this as well. Okay. Lastly, but not leastly, we're going to take here x to the power of 3 plus 2x squared minus 6x plus 1. And we're going to divide it by x plus 2. Now, keep in mind, like I said, make sure you have placeholder terms. Make sure your terms are in degree order, descending order, and you should be okay from there. Okay, first thing we're going to do is see what how many times does x go into x to the power of 3? It goes in x squared times. So we'll write that here. On this line, we're going to write x squared times x plus 2. So x squared times x is going to give us x to the power of 3. X squared times 2 is going to give us 2x squared. So we're going to minus this. So x cubed minus x cubed is 0. 2x squared minus 2x squared, also 0. So that means we could just bring down these two terms. So we have negative 6x plus 1. So if we take negative 6x divided by x, so how many times does x go into negative 6x? It goes in negative 6 times. So we're going to write our minus. On this line, we're going to write negative 6 multiplied by the x plus 2 term. So negative 6 times x is negative 6x. Negative 6 times 2 is negative 12. And we want to subtract this at high speeds. So negative 6x minus negative 6x is 0. 1 minus negative 12 is 13. So this one's the corresponding statement. So we write this as x cubed plus 2x squared minus 6x plus 1 is equal to the divisor, x plus 2 multiplied by the quotient plus the remainder. Okay. And the reason why I know this is going to work is because if you notice on the, and this is actually a technique we're going to be studying later, we have a 1 at the end. And I know that 2 times negative 6 is negative 12, and negative 12 plus 13 is 1. So chances are this probably out. Okay. So you're good to try out key question 1. And key question 1 is some 10 or 12 of these things for you to try out. But I do encourage you to try out some of the ones that I did here, just so that way you know that things are going according to plan. And you can also check your answers against the support. If you try out some of the support questions first, you can also try that as well. On the lesson of next time, we're going to be continuing on with more long division of polynomial, as well as some applications thereof, just to kind of see what we can do. But for now, we're going to end on time instead of a little bit late. So I'll see all of you next time, and goodbye for now.